keep going, Elise. Like, one more page. There you go. Y'all find it? Okay, so what we're going to be doing is actually calculating our weight on Earth, the Moon, Mars, and Jupiter. So we've been talking about it, and we had the computer program calculate it for us, but we are actually going to calculate it ourselves. So weight is a measure of the force of gravity on an object, and the force of gravity is not a constant value in the universe. So it tells us the force of gravity for each object that we are on. It says, for example, the force of gravity on the surface of the planet Jupiter is more than 2.5 times the force of gravity on the surface of Earth. We can use math to solve for the weight or mass. We're mostly going to be solving for weight because we know the mass of a lot of objects. So, what we have to do is get all this stuff first before we can actually calculate the weight, because otherwise we don't have an equation. I'm going to give you guys this. So, FG or W, what's our best guess? If we're trying to solve for weight, what's our best guess about what W is? It's weight. Sometimes it's called Fg, which is the force of gravity that's acting on you. Sometimes it's called W. It depends on which worksheet you're on, depends on where you're looking. Sometimes Fg, sometimes W. I'm going to try to use W as much as possible because I think that one's way easier to remember which letters they are. What's M? We've had the same M all year. Mass. And then what's our best guess about what G is? Gravity. Okay, this triangle works like every other triangle that we've had. So if numbers are next, or letters are next to each other, you multiply. If one's on top of the other, you divide. So if we're trying to solve for Fg, which is also weight, trying to solve for weight, what are we going to do to M and G? Multiply them. So our equation to solve for weight is mass times gravity. If we're trying to solve for M, what do we have to do? Yeah, we have to divide weight by gravity. Okay, so it wants us to calculate our weight on Earth, the Moon, Mars, and Jupiter. Place your answers in the blank space on the appropriate scales for each planet. The gravitational pull for each planet is listed in newtons per kilogram. We cannot use pounds in our equation because what are the two things that we can use mass in? What are the two units? Kilograms and grams. So we're going to take our weight in pounds, what we call weight, like you get from the doctor's office. We're going to transfer that, convert it to kilograms so that we can actually use it. So I'm going to do mine. I'm going to do mine in pounds, and then you're going to do yours. So, 130, you guys write this down because this is the teacher example, that way you have it. Then you guys are going to do yours in a minute. And I have to convert it. So what's the thing that I have to use to be able to convert from English to metric? Yeah, Genevieve was saying this thing. Okay, it's called dimensional analysis. So we have to use this thing, our picket fence. And what goes right here? What are we starting with? 130. 130 pounds. They give us a conversion factor of 1 kilogram equals 2.2 pounds. What do I put down here? 2.2 pounds, and then what's left over? 1 kilogram. Okay, what's the very first thing that I do before I touch any numbers? Cross out my units, so I can get rid of this pound and this one. So I know that my ending unit is going to be kilograms, because that's the only thing that I have left. What's my first step? Do I multiply or divide first? Multiply, so I end up with 130 times 1 kilogram divided by 2.2. So that is 130 kilograms divided by 2.2. And that equals 59 kilograms. So that's how much my mass is in kilograms. You guys are going to do the same thing for yours. It's the exact same process, but instead of 130, you put however much you weigh based on the last time you went to the doctor, or just whatever made-up number you feel like you would like to weigh. I don't really care. You're the only one that's going to see this. I'm not going to have you show it off to other people. This is just for you. You, all you. I'll scroll on a little bit, that way you can see it. Whoop. All blurry there. So remember, we're using dimensional analysis. So you have to cross off your units, the ones that are the same. You have to multiply the top numbers, then you divide. So 130 divided by 2.2, I ended up with 59. So you're going to do yours in this box right here. You're going to do yours really quickly. Because it wouldn't be fun to walk around and say, I know how much Miss Klingenberger weighs on Jupiter. It'd be more fun to say, I know how much I weigh on Jupiter. So you're going to do yours. You need a calculator. There are a whole bunch up here too. Okay, so I'm going to show you guys how to calculate your weight on Earth. We're going to walk through how to do the moon together. Then you guys are going to do Mars and Jupiter. So, you guys told me that M is what? Mass. So where do I find my mass? Where do I find it on this sheet? How about I find it what I just calculated? So mine's 59. Yours is whatever you just calculated in this box right here. Whatever you calculated, that goes right here under mass. And we're trying to find weight, which is FG. So we're not going to write anything in that one for right now. We don't have anything to put in there because we haven't done any calculations. G, on the other hand, is gravity. Why they called this F, I'm not sure, because it's not. This is gravity. So our number for gravity is always going to be found written on our planet here. So for the Earth, it's 9.8 newtons divided by kilograms. And I'm going to show you how that all works out in just a second. So you should all have the same G, but we should all have a different mass. So whatever your mass is, that goes right here. G for gravity, we find on our planet. Okay, we already found our formula earlier, and our formula is W equals M times G. So it wanted us to write down the formula. This is the first thing. The second thing is we plug in our numbers. The third, we get some sort of numerical answer. And then the fourth is we write a unit. So this is our first step, writing our formula. Second step, we have to plug in what we have. So my mass is 59 kilograms. You're going to write yours. Times 9.8 newtons divided by kilograms. So that's step number 2. Step number 3, we have to get some sort of number. So my number ends up being 572 because I multiplied 59 times 9.8. And I'm going to leave this as kilograms times newtons divided by kilograms, just for now. Well, we're going to get there. But for now, I'm just leaving everything that we had as a unit. I just want a number right now. So because step 3 was getting an answer. We're going to get to step 4. That's going to be getting the right unit. Step 3 is just getting the right number. So whatever your number is, you have to multiply your mass times 9.8. That's your weight. And then our last step is figuring out our units. So you can think of this kilogram right here as being kilogram divided by 1. So it's technically on top, and this other kilogram is technically on bottom. So if we have 1 on top and 1 on bottom, what do we get to do? Cross them off. So we can get rid of this, and we can get rid of this, and what do we end up with? Yeah, newtons. So there we go. Our final answer is my final answer is 572 newtons. Yours is going to be something between like 400 and 900. It's going to be somewhere in there.
And the final answer, the upper place.
Then you write your final answer under FG. Whatever you get as your final answer goes under FG. Okay. So, flip to the back. We're going to do the moon. You guys are going to help me get through the moon. So, first thing that we have to do all together is, what do I write right here? What do I write right here? Mass. So, write whatever your mass is. Wait, when did you figure it out?
The middle one.
It's the same one that you calculated in the first place. So mine is still 59. Calculate it in the very first thing we did was calculate that. Gets to hang out with us the whole time. We're still looking for FG because we're still trying to find weight, so we're not going to put anything there. What do I put right here? 1.6 newtons divided by kilograms. So that's the first thing we have to do, get that set up. What's the next thing that we have to do? What's our box tell us we have to do? What's the box tell us?
Formula.
Write the formula. So somebody tell me what's the formula?